Hey everybody, so this video I'm going to take a moment to show you guys a project I have been working on this year. Well, this is actually one of 3 examples. These are 3D printed traffic signals that actually run off of an Arduino Uno, which is right over there. So these were printed off using PLA. Everything was PLA in various colors, both transparent and non-transparent. So this intersection here has 11 signal heads total, simulating a 4-way intersection, along with protected left turn signals on the primary street, as well as a protected permissive doghouse cluster on one side of the side approach. So the whole idea with this intersection was, just for the heck of it, I would use up every single output available on the Arduino Uno. So this is, again, if I didn't mention that, my place of work is a community college, and one of the things that we do here is we actually have a kit that we give out to students in one of the early classes where they get to solder together an Arduino Uno. You can see this Arduino Uno was put together with 3-hole components. I actually soldered this one together, I think 2 or 3 years ago, and this one ended up in this traffic signal control. So you have the Arduino itself, and you have this breadboard over here to the side. It has essentially BJT transistors that switch on the power to the various lighting circuits. So for example, we'll just use these 2 here. For example, these 2 lights are tied together. The red, yellow, and green circles and this one are tied together. These 2 separate arrow left turn signals are tied together, which we'll see those in a moment. We've also got these 2 signals here tied together, as well as these 2 signals tied together, and we have this left turn signal here. So we have multiple circuits in here, and most of these were wired using RJ11 phone line, 4-conductor phone line. The doghouse down here actually has Cat5 going to it because I needed extra conductors for the turn arrows. But anyways, come back over here. You can see where all these come in here and interface with this breadboard. You have your various red, yellows, and greens, and your grounds. And so we have this powered off USB. And of course, pardon my messy desk. It's just like the computer room at home. USB power comes in through here to power the Arduino, and of course the USB connection can be hooked to a computer to flash code to this Arduino. But right now it's just running off of a power source, like a phone charger. Power comes into the Arduino, and of course you have the Arduino itself, and you have your digital outs. So this Arduino, I'm using every single digital out as well as every single analog pin. The analog pins can be configured to be a digital out if you wish, so they're all getting used. Right there is the brains of the whole operation. It's a Atmel ATmega 328P microcontroller. So the way this works is the Arduino sends out digital high or digital low signals to the bases of these transistors through a 1K ohm resistor, and when the output is high, it switches the transistor on, which switches on power to the various lighting circuit. And I'll take some time to go over the code later in this video, which is quite interesting. So if you look at these lights, most of the parts in the signal heads were actually found, at least the files were found, on Thingiverse. I did not model most of this stuff myself. I actually found this on Thingiverse, and I downloaded the STLs and printed them off. However, I should note that I had to make some changes and additions to make this work the way I wanted it to work. And I'll put a link down into the description, so that way you can check out the page on Thingiverse, because I'll say the author who designed these STLs did a fantastic job on them. Because the way it works is you have the various parts, such as the box, the door, the hat or visor, the lens, the reflector, as well as the LED mount. The things I made were these hangers. Each one has a hanger, because the original design had these attached to a pole. I prefer to have them hanging like you see them oftentimes in real life. And also for this T-head and the doghouse cluster, I had to model up brackets to assemble those together. I did that in Tinkercad. And also for the arrows, I modeled up flat lenses. So if you look, for example, these lenses, at least the two reds here, are convex, whereas the arrows are just flat. And the arrows, I made those myself, and I think it was originally paint, and then I went into Inkscape to create, I think it was an SVG, so that way I could, well, perfect, got an arrow, so that way I could vinyl cut those here in our Fab Lab. So we have a vinyl cutter, which is like I think it's a Cricut, something like that. I use those to cut out these arrows, which just adhere into the back of the flat lenses. And I think it looks really neat. Another thing I had to find was a diffuser for the LEDs. So the LEDs themselves, if you were to just use only the LEDs, the lighting performance would not be that great. I was going to try to pop it out, but it's not wanting to come out. It fits on there really, really snug, by the way. So I printed those off in clear PLA+, and those give these things more of a light bulb style appearance. What these simulate, or what these intend to look like, are the old-fashioned incandescent light bulb or halogen light bulb, where they ran traffic signals back in the day. And this intersection here is designed to, at least the way it was built, was to mimic that of a typical Charlotte DOT intersection you would find in the 1990s, or I guess we could say an NCDOT intersection, except their signals did not have the black visors. Now you're probably wondering, okay, why does this thing look like a face looking at you with two red eyes? Back in the 1990s, and actually through the middle late 2000s in North Carolina, at intersections where you had a single left turn signal like this, protected signal, where you had a single left turn lane, you typically had two reds, because with the incandescent bulbs, if one burned out, you had a spare. So, and also back then, they typically did not run red arrows, at least in the single T-heads like this. They had just the solid reds and this accompanying left turn signal sign. Now, in a moment, I'll go around to the other side and show you what the double looks like, or the double turn lane signals look like. But yeah, really, really neat. And also, I should note, these signs, I modeled these up in Tinkercad, and the actual signage was printed off and taped on to these 3D printed pieces. So we'll go ahead and take a look at the other side. So on this side, it looks, let's say, more typical what you'll see today. Because back in the 90s and the 2000s, when they were running incandescent bulbs, back then they ran left arrows, or red arrows, in the left turn signals at a double turn lane. But if it was a single left turn lane, you had a T-head with two solid reds along with a yellow and green arrow. This is how they did it back then, and that's what I did when I modeled this up. So in North Carolina and many other parts of the U.S. now, at a single left turn lane, you would just have one of these instead of that. So I'll go back around and show y'all more of the internals of these things. I don't think I showed you that yet. I had some spare parts here. So this was a spare doghouse cluster. I was going to have 2 different doghouse clusters on this, and I may still actually install this at a later time to put a parallel right turn movement, or with arrows that parallel the left turn on the other side. But this is what the inside of the actual signals look like. So all the different boxes, they are super glued together. On my FlashForge Adventure 5M Pro, I can print off 10 boxes as well as 10 doors, and I think it takes about 2 hours to print them. So it's not too bad. This is an assembled lamp assembly. Again, I had a couple of spare lamps here, a couple of spare arrows. So this is the green arrow for the doghouse. So essentially here I use metallic silver filament to print out the reflectors, and in addition I had also spray painted them too to give them an extra reflective appearance, because you want them to act like a mirror to reflect light and improve the efficiency of the lighting. So there's the LED with the diffuser installed in a reflector. I think this one that popped off of a different door assembly. I have to glue it back, but that's kind of what the insides look like of these things. Now, of course, there's wiring inside here, as well as resistors for the LEDs. Now, with these, I use as few as resistors as I needed. For example, a typical 3-section would only need 1 resistor, and I would install it on the ground side of the LEDs. The T-head, there's 3 resistors, 1 for each red, as well as a shared resistor for the yellow and green, because with these lights, only 1 phase is lit at a time. The doghouse cluster also has 3 resistors. You have 1 for the red lamp, as well as a shared one for the left cluster and a shared one for the right cluster. So right now it's giving a protected left turn movement, and you'll see it expire here in just a moment. And what's interesting about the code on this signal, or this intersection, is when I programmed these, this was my first time, or at least when I programmed the ones at home, which I have to show in a later video. When I programmed these, it was my first time really diving into Arduino programming. Now, granted, I had some hands-on experience with C++ back in the day, and Arduino is really similar to C++ as far as the code goes. When I programmed these, I wanted it to not be boring. Basically, it would be too boring if it was just doing the same thing over and over again, more or less going through the same cycle at the same time. It would be too boring if it was doing that. So I decided to randomize some things. So the way this thing works is this controller here, the Arduino, every time it loops through a cycle, it makes decisions on whether to, example, offer a green arrow on this left turn signal as well as the opposing left turn signal. And if it does offer a green arrow on those, it then determines how long to offer that phase, and there's a range, a minimum and maximum time for each. Sometimes they go almost the same time. Other times one will turn red quite a while before the other does. And same goes for the side approaches. So it can skip side approach calls. What it does is it more or less mimics the operation of a demand actuated traffic signal, because of course traffic conditions vary, and unless you're like in a city such as, like, for example, right out there, most of the signals in uptown Charlotte are they operate on more of a time sequence. But once you get out of the city, you start encountering more demand actuated signals that operate based off of traffic demand, and that's more or less what this does. So it's funny, one of our students here had remarked, he was sitting here in the lab and just chilling out, killing time in the lab, watching these things, and it got his attention when the next time it cycled around, it didn't do the same thing. I was like, yeah, I said, I said they kind of do their own random thing. So it's pretty cool to sit back and watch it. So give me just a moment here. I'm going to pull up Arduino and I'll show you the code that runs these things. Okay, so here's a look at the program code for this particular intersection. So, as I mentioned before, this was kind of my first time diving into Arduino programming. Now, this is actually my third program, all things considered, because this is my third intersection. And more or less what I did is I had started out by copying off the code from my home-based intersection, which was a T intersection, but I had two different left turn signals, one acting as a U-turn signal, which I'll cover in a future video. And I added additional code to operate this doghouse cluster for the side approach, for that protected arrow for the left turn. So the first thing we do is we declare all our various values, such as the variables used for the outputs, as well as variables to keep track of various things, including timing and things like that. The first thing it does when you start this up is it runs through a flash sequence, and I call it blink lights here, but it really is flash mode, where the traffic signals all flash, and it does it for like 10 seconds or so. And I can adjust this by changing a certain number in here. Anyways, now here is like part 2 of the left turn signal sequence. So the thing about these left turn signals, since there's 2 of them, one for each direction, they both operate at the same time. Therefore, the Arduino has to use the millis function to keep track of time, because the Arduino is having to do multiple things at the same time here. The rest of this intersection, outside of the protected left turn signal sequence, operates off of more or less delays. So if we go down here to, actually, let's go down to the bottom and show y'all the setup routine. So this is where it sets all the pins as outputs, including those 6 analog pins. It goes to the blink lights loop, which is the flash. It does this on startup. And then it goes into the regular loop that goes through over and over again. So the first thing it does is, for the straight green, it decides how long to offer that phase for, more or less the resting phase, like this right here, when both are green at the same time. It decides how long to keep those lights green before it runs to the next part of the sequence, and that can range between 12 seconds to 60 seconds. So after that, what it does is it goes to the side call, and it makes a decision whether to offer a green arrow, or excuse me, a green light for the side call. And here is some code I have in here just as sort of a safety net in case the millis variable is about to roll over back to 0. More or less, if it gets up to that point, it just tells it to not offer a call for either left turn signal until that resets back to 0. And then there's a straight cycle and side cycle. There's 2 different parts of the program. I'm sorry if I'm not explaining this very clearly. But so we'll go back up to, let's see here, try to walk y'all through the whole thing, how it works. So, all right, here we are. So, straight cycle includes code that begins the left turn signal sequence. I have more or less the 2 left turn signals included in the straight cycle. And what it does is it first checks to see if the calls are present for either one. Now somewhere I think near the bottom is where I actually have it. Yeah, right here. There's LTS call present, LTS2 call present, and LTS call 2 present. There's 3 different ones. Let me see here. Yeah, that random 2 plus 1, that's where it decides whether to offer a green arrow or not for both the primary left turn signals as well as the arrow on this doghouse, I do think. It's been a little while. There's so much in here. Anyway, straight cycle. Okay, so what this does is, let's say for example, when it begins a straight cycle, let's say the timer mentioned earlier for the straight cycle, the straight green time runs out, then it checks to see if there's a call for the side. Let's say there's a call for the side. Okay, it loops back to straight cycle again. What it does is, the first thing it does is it checks for calls on the left turn signals, because every time this loops around, those random number generators, they do their thing and generate a random number, either 1 or 2. And I think if it's 2, it means yes, there's a call present. So what this will do is, this first code, what it does is it will check to see if these straight through lights are green. If they are, then it cycles them to yellow, then they're red. And it can do one or the other both at the same time. And here is where it uses the millis function to store and keep track of time, because it needs this for running either one or both of the left turn signals in this case. Just going to briefly run through all this. So once it gets to this step here, it goes to LTS finish. Like I said, I could have done this a whole lot differently. I know someone's going to probably say in the comments, well, you could have done it this way, you could have done it that way. Well, hey, it works. So go to LTS finish. All right, so LTS finish, when it begins here, either one or both of these left turn signals are currently green. And then what it does is it gets the current millis and stores that. Well, actually, first thing it does is the start millis, it stores that variable, and then it begins grabbing current millis every time it goes to this do while loop. And what this does is it checks timing, which again are just random numbers that are generated every time these things get a green arrow. And what it does is it loops through this over and over again, and once it gets to a certain point, let's say for example, once the green time runs out on either one, it turns off the green light and turns on the yellow light, and then the yellow light interval on the left turn signals is 3.5 seconds or 3,500 milliseconds. That's the next thing it checks. And then once that timing has been reached, it turns off the yellow light and turns on the red light. And then there's the 2-second pause between these going red and the opposing straight light going green. So what this does is this will continue looping through until both of these are back red again. So I know there's a lot there, and it's a lot of code. Most of the code in this program has to do with these left turn signals. Now, for example, if I go look up my code, the original code for my home intersection which was just a T intersection. It runs completely on delays. Since there's only one left turn signal, my home intersection originally just had one left turn signal, so therefore it could operate just off of delays. As you can see, I'm just going to briefly scroll through the code. There's a whole lot less code here versus the four-way intersection or the T intersection with double left turn signals, because in that case, as mentioned, the Arduino is going to do two things at the same time. So that being said, before we wrap this up, I'm going to show you all my second intersection here. I have two intersections here at my place of work. I have this one, and I have one upstairs in our fab lab, which has a flashing yellow arrow. So let's go have a look at that before I end this video. Okay, everybody, so this is my other intersection I have here at my place of work. This one is basically a replica of a modern flashing yellow arrow T intersection. So it's a T intersection with a protected and permissive left turn signal that either has a solid green for protected left turns, or a flashing yellow arrow for permissive, more or less, yielding to oncoming traffic. So this one works solely off of the random number generators like I discussed earlier, along with delays. And I have this code here for people to look at. Yeah, not the best code, but hey, it works. That's the key thing. So this was the one I put together back in the spring. The one downstairs I just showed you, I put together this past summer. So this one, as you can see, it's just sitting on this crooked mount. Honestly, the mount was like a last minute thing, because I was originally going to hang these up on the ceiling somewhere, but I decided, you know what, let's make them work and be moving around. So this is a look at the control box, and you can see the wiring is not quite as neat. I used jumper wires or jumper leads to wire this one together, whereas the one downstairs was wired together with jumper wire, solid core jumper wire. And I am planning on possibly rewiring this one at some point to make it look a little neater. So if we look here, we have, let's see, 1, 2, 3, 4, 3 sections, along with 2 doghouse clusters, as well as this 4th section. So there's a lot more Cat5 wiring in this intersection because I think, yeah, with the exception of these 3 sections down here, which use RJ11 conductors, the rest of them are using RJ45 because I needed, in some cases, all 8 conductors. So this one right here has right turn arrows that parallel the side approach. This one has right turn arrows that parallel the protected left turn. So if we look here, this one, we're not using up all the ports. We still have, let's see, all right, if I look here, okay, it looks like all 14 or so of the digital outs are used, or the digital pins. We still have all 6 of the analogs, so we still have some we still have some flexibility here where I can add additional functions to this intersection. So yeah, it's pretty neat stuff. So this one, I know I showed you the code earlier, but like I say, it works totally off of delays. And like I say, it's kind of hard coded in to operate this flashing yellow arrow, because there's several different scenarios where this thing will, it's either when this light here goes green, sometimes this one will go straight to flashing yellow, sometimes it will go to a green arrow, or let's say if it finishes the straight cycle and it finds there's no call present on the side, it can then go back to this, and let's say there's a call present for a green arrow, then it has to turn this one yellow, then red, and then turn this one from flashing yellow to green. But yeah, it's pretty neat. It's definitely an attention grabber when people come into this lab. Same as the one downstairs. And this one was pretty much the same way, using pretty much the same parts. Let's say I had a lot of fun putting this together, although it was quite a lot of work. I'll be honest with you, it's a whole lot of work. Hey everybody, thanks for watching this video from Tinkercad channel. If this is your first time, please subscribe to the channel and tick the bell so you get notified of a new video I post. Please like this video if you enjoyed it, leave a comment, and share this video as well as the channel with your friends to get the word out. In addition, I have a second YouTube channel, that's CubeCompMTDX. Again, I hope you enjoyed this video, and thank you so much for your support.